So for my first equation, you have to prove, or I had to prove, the power property of logarithms, which is basically how you can have a logarithm and take what is inside of the logarithm, take its exponent, and basically move it to the outside by multiplying the entire logarithm, and how those two are basically equal to each other. I started by taking the basic, just the log base b of x without the exponent in place here and making it equal to m. I converted that into the exponential form to make it a little easier to introduce the exponent. In this case it's r, but in our case it's k. And basically raised both sides by k, simplified it. Then I took the log base b of both sides to get rid of this b over here, because the log of something with the log of something that is the same as its base is equal to 1, and after that we just bring mk down, making it log base b of x to the k power is equal, log base b of x to the k power is equal to m times k. After that, all I did was replace m with the original log base b of x. So now you can see how log base b of x to the k is equal to log base b of x times k. Kind of went full circle over here. It really goes to show how, in detail, how you can take the exponent here and bring it to the outside. For question number 2 is how to find the domain of g of x is equal to the natural log of 5 times x times 3. And the way to do it is, first I simplified g of x is equal to the natural log of 15x. And the way to do this is find if what is inside of the log is positive, because if it is negative, the log is not real, or it is not included. So 15, basically just finding the positives of 15x has to be greater than 0. After doing very little manipulation, 15 divided on both sides, you get x is greater than 0. So we know that in this case, our domain is going to be all positive values. So it's 0 to positive infinity. For question number 3 is, how do you know if the equation of an exponential function is going to be increasing or decreasing? Basically, all you have to do is see if the exponent is positive or negative. If your exponent is negative, the graph will be decaying or decreasing, and if it is positive, the graph will be increasing. And so the way you can kind of understand this is, if you have a negative power, the results you're going to be getting are small numbers, usually from 0 to 1. Basically smaller and smaller numbers as that negative power increases, or should I say decreases. So as the power becomes negative, your y values, or the answer, or the output will be smaller and smaller and smaller. And if you have a positive exponent, the values will be growing, and in that case increasing exponentially. Basically, if you have a negative power, your negatives are going to be increasing, making it the left side of your graph greater or higher than the right side, showing a decrease. And if your and vice versa, if your power or your exponent is positive. And question number 4 is, create your own example of a log function and explain how to graph it. So there are a couple of translations that we can do to the base log function. So the base log function, log base or log of x, or log base 10 of x, is always going to have a point at 0, 1. If I'm getting that right, it's going to hit the x-axis at 0.1, or at 1, and all we have to do is see what is around this equation, what's inside this equation, to see how we can shift that graph. In this case, it's +1. If we have anything that's being added inside the log, is going to shift that many spaces to the left. In this case, it's 1 space to the left. And if we have anything that is being subtracted, it's shifting to the right. If we have anything that's being added or subtracted that's outside of the logarithm, we're going to see a vertical shift. So if we're adding something to the outside, let's say +1, it's going to be a vertical shift up 1 step. And if we have something like -1, it's going to be down 1 step. It's pretty simple. And if there are any problems along the way, you can always create a simple t-chart and plug in values for x and see what values get for y. Get a couple basic points. All you need really is like 2 or 3 points, and then you can graph it, because the majority of these functions are going to have a very similar, all of these functions are going to have a very similar shape of the rate basically increasing over time or decreasing over time, making it exponential. Kind of a curve. Every single graph is going to have that exponential curve. So my open-ended question that I would have asked on the quiz or the test is, if you have $5,000 being invested at a rate of 2% compounded monthly, how long will it take for you to double the initial investment?